So the question 21, a Saturn 5 rocket used in NASA space program, which is having a mass of 3.04 into 10 to the power 6 kilogram. It took off vertically with a thrust of 3.4 exponent 7. Show that the resultant force on the rocket is about 4 exponent 6 Newton. So how we can show? Example, if this was a rocket, the weight of the rocket will act downward. And the thrust of the engine will act upward. Resultant, what is the resultant force? Because two forces are acting in opposite directions. So what will the resultant force here? It will be equals to thrust minus the weight. So we have to show that the thrust minus the weight is equals to 4 exponent 6. So how we can represent that? Thrust is given, which is 3.40 into 10 to the power 7. Minus the weight. Weight is mass into gravity. So mass of the rocket is given 3.04 into 10 to the power 6. And what about the gravity? Expression due to gravity 9.81. So when we took the difference of these two, this will give us the force, and that force will be the resultant force. Means that this is a force which will cause the acceleration of this. So that will be about 4 exponent 6 or 4.2 exponent 6. So the resultant force will be equal to 4.2 into 10 to the power 6 Newton. Then we need the initial acceleration. How much this rocket accelerate? So we have the formula that resultant force is equals to mass into acceleration. Like whenever there's a resultant force, it will be equal to product of mass and acceleration. So resultant force, the mass of the result, we already have the resulting force from the previous part, which is 4.2 into 10 to the power 6. The mass of the rocket is also given, which is 3.04 exponent 6. So we can find expression. This part is multiplied, other side will be divided. So it will be 4.2 exponent 6 divided by 3.04 into 10 to the power 6. So when we divide them, this will give us the acceleration. That's about 1.38 meter per second square. So this is the acceleration of the rocket. Then after 150 seconds, the rocket reaches a speed of 2,390. Now we have to calculate its average acceleration. So how we can work out its average acceleration? As the rocket is launched, its initial velocity will be 0 meter per second. It reaches a final speed of 2,390 meters per second. And it took 150 seconds. So if you want to work out the acceleration, we can use equation of motion B is equals to U plus AT, or acceleration is change in velocity divided by time. So it will be 2,390 minus 0 divided by 150. So when we divide them, this will give us 15.9 meter per second square. So you can find the initial acceleration was only 1.38, but the average acceleration is higher. What might be, what is the account for the difference between the initial acceleration and the average acceleration? Why they're different from each other? Because what happened, why, like it's not same, the mass of the rocket is continuously changing. So if the mass is continuously changing, its acceleration will also change, as we have the formula that F is equals to ma. So F divided by m is equals to a. This mass is decreasing. If the mass is decreasing, it means the acceleration will increase if the resultant force is constant. So the mass of the rocket is continuously changing. That's why the average acceleration and the initial accelerations are different from each other. So it suggests why the initial acceleration and the average accelerations are different. So simple answer here, because the mass of this rocket is not constant. If the mass of an object is constant, the initial acceleration and the average acceleration will be same, as the mass of an object can affect the acceleration.